Hello everyone, I'm Yaara Erez. I'm based at Bar-Ilan University in Israel, and much of the work that I'm going to talk about was done at the University of Cambridge, where I was previously based. Our aim in this research is to functionally map regions in order to spare the resection during surgeries, and we want to develop tools and methods to allow that and provide clinicians with this information. Ultimately, we would like to improve overall patient quality of life. We are employing a multimodality approach, and I'm going to talk about ECOG and fMRI today. We focused on executive function in this study. This is a collection of cognitive processes, including attention, task switching, working memory. And we know that these processes are supported by a frontal parietal network. This is a domain general network, bilateral, and we have robust evidence from our work as well as others that this network is recruited whenever cognitive demand increases. In patients with glioma, executive function is often damaged after a surgery because of the resection, but it is very challenging to map during the surgery, mainly because of the complex nature of these functions and the distributed network that supports them. There is only a handful of studies that looked into that in the literature. So in our work, together with my former student Muataz, we recorded ECOG during awake surgeries. So patients are awake and we ask them to perform two counting tasks with increased demand to recruit executive function regions, an easy counting just from 1 to 20, and then a harder, more demanding task counting while switching between letters and numbers, 1A, 2B, 3C, and so on. And what we found is that increases in high gamma activity were associated with the increase in cognitive demand, and these are the red blobs, primarily in the frontal cortex, and this is where we would expect to see regions that are associated with executive function. To more formally link these increases in high gamma activity to the frontal parietal network, we looked at electrodes that were placed in different frontal networks based on the HCP parcellation, and indeed these increases were only specific to the frontal parietal network in the orange bar, and distinguished it from other adjacent networks such as the DMN and the language network. What I showed you so far is data from healthy appearing tissue further away from the tumor. And what Ayan was interested in is what happens on in tumor infiltrated cortex much closer to the tumor itself. And here we used both ECOG to look at activity locally, the vicinity of the tumor, and resting state fMRI data from before the surgery, and constructed functional connectivity maps. So we have some accumulating evidence that the tumor interacts and interferes with the cognitive, functional circuits and cognitive in particular. And what we can see here is that not only we have some responsive electrodes in tumor infiltrated cortex, also functional connectivity patterns are preserved at least to some extent. Pulling together all the data from patients and electrodes, we found some preliminary evidence for this association between local activity, as we measure with ECOG during surgery, and strengths of functional connectivity with different canonical networks, and particularly the dorsal attention network, where attention is a hallmark of executive function. This work is a part of a larger longitudinal study with multiple imaging modalities and cognitive assessments. We are about to start its second phase, and I'm happy to talk about it further if anyone is interested. Thank you very much for your attention.